So I'm going to have homework 5 up tonight, and it's due. I didn't write the date down. Not this weekend, but I think next. This one would be 3rd. Okay, it would overlap with your test for a few days, but I think that will be all right. So we're going to have that homework due on Saturday, the 10th.
Professor, what topics are on homework 5?
Chapter 17.
Thank you. And then we're doing notes for chapter 17 this week, and we're going to review next week, and then do exam 2. The dates are, well, the plan is to post the test on the 6th. And you'll need to finish the test by like the 15th. And this is chapter 16. This is chapter 17. And test 2 is on both chapters, just kind of more 16, but just a little bit from 17. Okay. Any questions? All right, so let's go ahead, do some notes. I have a reminder of something we did last time. Just started talking about random variables that have a normal distribution. So you have a random variable. We'll just go ahead and sketch. So your random variable, we call it x. And I'd like to draw the x this way, but it's just a x. Okay. This is a number line for x going from negative infinity to positive infinity. And then for that variable, we have a distribution over like all possible values of the variable, and it's centered at the mean. So we're going to kind of mark that part in the middle. Mean, I also like to put the subscript to x, but the mean is mu, or mu sub x. Okay. Distribution has a peak above the mean, comes down, and it's symmetric, so the other side's supposed to match. And then halfway between this curve from like shifting down then back up, is an inflection point, and that's going to go like halfway here, kind of halfway here. And inflection points happen at the mean minus sigma, which we're just going to put the mean as mu. Mu minus sigma. The other one is here. Mu plus sigma. That's a number. So we're going to draw one together where the mean is 10 and the standard deviation is 4. Okay, but we're going to introduce the variable. So x will be a random variable. Normal distribution. Okay, and the mean is mu equal to 10. Also, the standard deviation is 4. Sigma, so sigma equal to 4. Okay, so we're drawing a bell curve centered at 10, and those inflection points will be at mu plus 4 and mu minus 4. So sketch a graph. The graph. Thanks. Okay. So again, the normal distribution is a bell curve. And the variable we called x, so start there. Right here, we've got values for x. Like towards negative infinity, positive infinity, and 10 we'll put in the middle. All right, I think just for a good sketch, it'd be nice to just draw the bell shape and then mark the inflection points after. So we have a peak above 10, go down. Don't cross that number line. You approach it, but never cross it. This side's supposed to match. It comes over, never crosses that x-axis. Okay, so mark your inflection points somewhere where it starts to go from down and then back to up, right about there. It's like down and up, so kind of here. Okay. So inflection points occur at 10 plus 4 and 10 minus 4. So here at 6 and at 14.
And I think that's as much as we'll do for these graphs. Okay, this next one, you're given the graph. We'll just say consider the following distribution. It's a bell curve. It's going to go down, down, and it's sitting over, oh. Let's put the number line. So it's over a number line with all the values of some variable we'll call x. Okay, so this side's supposed to match that side. Try. Oops, it's the same thing. Well, it's just, I should try to do a better sketch. I can do this. Here, here. That's good enough. Okay. The center is 9. And inflection points at, let's see, 3 and 15. Okay, first, what is the mean? Okay, this graph centered at the mean, so it's going to equal 9. Cool. What is the standard deviation? So you can either do 9 minus 3, so the difference between that inflection point and the mean, or this side, 15 minus 9. So it's like the distance from here to here. Or since it's symmetric, you can do the other side right there. Okay, so sigma is...
Hey, Professor, I have a quick question just regarding the inflection points. Do each of them, I mean, I know that when we graph, we have both, like we have mu minus minus sigma and mu plus sigma. Do the lower and the upper inflection points like each have their own name? Like, would you ask us like what is, like if you wanted us to specifically find what the upper bound, I guess the upper bound inflection point, like the higher number of inflection points, do they each have their own number, or are we just simply like usually just given simply what's the standard deviation versus finding the individual ones? If that question made sense.
Yeah, I know what you're asking. And the answer is focusing on the standard deviation, not so much the inflection points, but like finding this part.
To find the space, not the actual point.
Yeah. But I could just be clear and say like the lower inflection point would equal this, and the higher or upper inflection point would equal that. So. But they don't have special names.
Thank you.
There is something that we might talk about next time
that's kind of like a little bit more going on with these standard deviations. It's called the empirical rule, but maybe we'll just do that at the end of all of this stuff, like for fun, not put it on a test. Okay, so we're trying to find, let's do 15 minus 9. 6. Or you can find this distance. It'd be 9 minus 3. Still 6. Okay, I'm gonna write that. I'm gonna do the empirical rule. Okay. One more like this. So I'm going to draw the graph, and then you're going to read from the graph. Okay, so we have a distribution. Okay, so new example, new variable, but I'm still going to call it x. Okay, let's go here. I think we're good with the stiff. All right. Let's start with x. Okay, we are over a number line. I'm going to mark the mean. It's 70. And we're going up here. It's a normal distribution, so we're over like that. Cool. So let's call this an inflection point. That's an inflection point. We'll come over here. Okay. Then we're at 50 and 90. So first part, what's the mean? Um, 70. Next part, what is the standard deviation? So sigma is the distance from here to here, or you can find the distance from there to there. It's the same. Okay, so we can do like 90 minus 70, which would be 20. Or you can take 70 and subtract 50, and that leaves that space that's between. So we're going to switch it up a little bit. The next focus is areas that are under the curve. So let's use this picture for now. Under the curve is 100% total area, so one total, which makes, let's say, half
this. 50% or 0.5. Okay. The reason we are interested in areas under the curve is because they represent the probability of observing, we'll write this all down by the way, is the probability of observing the value of the variable in that interval. Okay, so we found the mean, we got that standard deviation, and now we're gonna do area. Area under the graph of the normal curve. On an interval represents the probability of observing a value of the variable in that interval. Okay, I can squeeze this last part in. So I think I'm going to try to remember that a place to get started with these is talking about the interval that we're interested in, and then looking at the area under the curve, and then knowing that that area represents a probability. So right now I have some with just kind of numbers. Next time I'll get into ones with a little bit more going on, kind of like a word problem, but same process every time. All right, this example. Okay, we're doing this one. Let X have a normal distribution. With mean 24, a mean of mean. And
standard deviation of 13. Okay. So the rest of this problem comes from using either a z-table or a online calculator. I used a online calculator. So I found that the area under the curve the normal curve, the normal distribution. To the right of 26, of x equals 26, okay, so I did put a lowercase x because we did pick a specific value of x. I'm not super picky about it though, just clear that it's your variable x at this value, and the area to the right of that number is 0.44. Okay. Find the probability that x is greater than or equal to 26. So I like to draw a picture for these kinds of problems. And then once we have a good picture, we'll write down the answer. So the normal distribution is a bell curve. And it's centered at the mean, 24. Okay, let's move this a little bit. Let's make this the center right there. Okay. We can mark these inflection points. So 24 plus 13 would be right here. We don't really need these parts, but it'll take some time to mark them. Cool. So it'd be, let's see, didn't keep it in my notes. So 24 plus 13 would be 37. 24 minus 13 would be 11, I think. 4 and a 2 will give me a 7 and a 3. Cool. We have the area under the normal curve to the right of 26. So let's mark 26. And we'll kind of talk about this after the problem, but you can draw a straight line up to the curve or a dotted line, doesn't matter. You just want to go from 26 up to the curve.
And then the area under there is on the right side. So over here on the right of that shade. Is 0.44. We want the probability that x is greater than or equal to 26. So let's get these are your x values. And we want x greater than or equal to 26. So we're just choosing that area. They're the same thing. Probability x greater than or equal to 26 is 0.44. Or 44%, either way. And then I wanted to put that note down that when you're talking about the area under the curve, this one little strip right here is such a small amount of area, it doesn't matter if it's filled in or if it's missing. So you can draw a straight line or a dotted line. It's not going to affect the overall number. That represents this area. So for probability, we're going to be looking at things like probability of x, let's say greater than a. That number is the same as having x, the probability of x, greater than or equal to a. So you can exclude a or include a. Either way, you're going to find the same area under the curve for like the probability of x on that interval or that interval. All right, let's do next. This time, we let x be a random variable. Mean mu equal to 0. And standard deviation equal to 1. We are going to have, or either using a z-table or a calculator, we find that the area that's under the normal curve.
Professor, in terms of like homework.
Yeah.
Professor, in relation to like when we're doing problems like this, whether on homework or the exam, would we be like when you say like the calculator z-table thing, would we be given that probability, or not the probability, but the area that area number, would we be given that, or are we expected to find that on our own? Or like in the homework
No.
problems, would you just give us x to the right of x equal point, like the previous one?
Yeah, I'll give it to you. I'm not going to cover like using the table or get too into like showing you the calculator. So I'll just go do it for you.
Okay, and we'll just be like expected to apply when we're given that number, we're expected to apply it accordingly.
Yeah. Like interpret what it means.
Okay.
So, and then also while we're kind of pausing to talk about what problems look like, I always like to keep, when we write the problem and we have your probability, I like to keep the variable in the first spot and then whenever symbol and then, you know, some kind of number. So I like to keep it a little organized like this as kind of a pattern you can see. So usually I'll have the variable in the first spot, some kind of symbol, like inequality symbol, and then a number. Okay, back to this. Okay, I went and found the area using Google, and it was on the, let's see, the area under the normal curve to the left of 4.6. Oh, sorry, 0.46. Okay. 0.677. Find. The probability that x is less than or equal to 0.46. And this we're going to call part A. So actually we're going to erase here. Okay. Okay, starting with this. And again, I like to draw the picture. So we have some number line for x, and it's centered at 0. The distribution is centered at 0. Standard deviation of 1. So an inflection point at -1 and +1. It's like right about here. And somewhere like there. Cool. All right. We want to mark 0.46 as one of the values on the number line. So it's positive and it's a little less than 1. Let's say like right about there. Okay. We're under a normal curve. And I'm talking about area on the left of that number. So that's the right side. We're going to go left side under the curve. And you can go with a dotted line or a straight line, either way. Go straight up. And then shade to the left. Okay, and that area is 0.677. Okay, and we're talking about the probability of x being less than or equal to 0.46. So x values, and at 0.46, you're going less than or equal to. So we want this interval. And the probability is the corresponding area under the normal curve, which you're given. So probability that x is less than or equal to 0.46 is 0.67. Oh, okay. All right. Next part. Find the probability that x is greater than 0.46. Okay, what we need is the area under the normal curve above the interval that we're interested in, which is the x values greater than 0.46. Let's find orange color, might look just the same, but this time we're at 0.46. We can include it or not include it. It's not really going to affect the overall probability. But we're here, going above that number this way for part B. So I want that area right there. What we're going to do is take the full area and subtract this area, which leaves the leftover space. So find 1 minus 0.677 equals. Okay, so here's the math, I guess, explanation. Probability that x is greater than 0.46 equal to, it's the complement rule. So take 1 and subtract the opposite. 1 minus the probability of x being less than or equal to 0.46. So that was that part. 1 minus 0.677. And I got I had a little extra decimals in mine, but it should be 0.322. Just gonna double check it. 1 subtract 0.677, 0.323. I think we have time to do one more problem. Yes. Okay, so starting fresh with our last example for today. going to let x be a random variable. Mean equal to mu equal to, we did that part. We're here at a mean of 50. Okay, and a standard deviation of 7. Then we're going to do this. The probability that x is greater than 65 is equal to 0.162. 0.0162. First part. Probability that x is less than or equal to 65. So we're going to do the complement rule. I would also like to draw the sketch of this graph, and then we'll see if we can do one more part to this problem. Let's do the sketch first. So down over on the side, we have a number line for x values. It's a, we need to mention that it's a normal random variable. So I'm going to put this in. Okay, that way I have my bell curve that's centered at the mean of 50. And I could mark the inflection points, but we don't really need to. What I'm mostly interested in is this number here, 65. So just past 50, we'll label 65. Okay. You're told us that the probability that x is greater than 65, so x values going from here over to there, is 0.0162. So what I can do is shade that area and label it 0.0162. But I'm interested in, or like part A is asking for, x values that are less than or equal to 65. So if you went from 65 and over to this way, less than. So this is what I want. So we'll do 1 minus 0.162, and that leaves that space we're looking for. math symbols, we would write probability that x is less than or equal to 65 equals 1, and then subtract the opposite probability of x being greater than 65. 1 subtract 0.0162. Okay, I got 0.9838. I'm going to double check really fast. Make sure it's correct. Okay. And then I think that we still have some time. So we're going to try part B. Okay, for the same random variable, we have that the probability of x being less than or equal to 58 is 0.8729.
Professor, what's the symbol? Is it less than or equal to or greater than or equal to?
Less than or equal to. Yeah, make it a little better.
Okay, thank you.
And find probability that x is greater than 58. So we'll do a sketch first, and then we'll work through the problem after that. Same variable x, and its mean was 50. And it was a normal distribution. Goes over and over. It's pretty good. Okay. 58 is a number we're interested in, so let's label that right here, just past 50. We're going to just draw a line up to the curve. Okay, so we know that x less than or equal to 58. So going to 58 and values that are less than or equal to would be this way. Has a probability of 0.8729. So the probability is the area under the curve above that interval. And they're told it's 0.8729. And find probability that x is greater than 58. So if you went, over here this way, you just need that area to find that probability. So this is what we want. It's equal to 100% minus this area, 0.8729. So like working through it mathematically, we have probability of X greater than 58. Equal to 1, and then subtracts the probability that X is less than or equal to 58. 1, subtract probability X less than or equal to, like we talked about earlier, including the equal sign or not including it doesn't affect the probability. It's just kind of the way that it faces that's important. Face this way, and we still have 58. Okay. We're doing 1 subtract 0.87. I got 0.1271. But I'm gonna check. Okay. So that's the end for the notes today. And I want to talk for just a moment about kind of why we're taking these notes. And it's, all right. So a lot of experiments have a normal distribution. There's just a lot of values in an experiment. Not all experiments, but a lot of experiments have values that tend to be in the middle and then kind of slowly get to extremes where maybe there's less high values and less low values in the overall like distribution. So next time I want to introduce problems that have things like heights or speeds or other experiments that have normal distributions, and then using these ideas to find probabilities for those experiments. And that will be the end of the chapter. Okay.